I'd like to welcome you to the AI Ethics in Research Context, the Current Approaches and Future Challenges. Our speakers are Dr. Kathleen Fraser, Dr. Terrence Stewart, Mr. Stephen Downs, and Ms. Margaret McKay. Just to save some time, I'm going to let you guys go to their bios and read them yourselves. Just a few housekeeping issues. If you can keep yourself on mute until the end if you want to ask any questions. So please use the chat function to ask any questions. We'll do questions at the end. Also, there will be a quick 10-minute break around 2:55-ish. At the end, as you've probably seen at other things, the session feedback survey will pop up at the end. And I will turn it over to the gang.
Thanks very much, Linda. You know, it wouldn't be a major event if there wasn't at least one technical challenge. So thank you to all who attended this or are attending this session. I'm Margaret McKay. I'm your moderator, and you will hear from me from time to time, including for the next couple of minutes. We are starting a little bit behind, and I want to respect everybody's time, so I am going to try to cut a little bit of time out of my presentation. The slides and some of the material in the slides in part one is important part two. So my recommendation is for everybody to go into the Carib schedule, click on this session under concurrent sessions, scroll down to the bottom and download the slides in the language of your choice. That will be useful to you because I am skipping some stuff just to make up a bit of time. Kathleen is going to handle the slides. Dr. Fraser, would you mind giving the next slide? So as Linda mentioned, we have a two-part schedule. Part one is where the four of us try to provide you with a little bit of background. This is going to build on a number of the other excellent sessions that you've heard today, and really focus in on the AI ethics piece of this as distinct from the sort of broader research ethics component. And then in part two, you'll be going into some breakout sessions. We'll be there to support you, and we'll be asking you to really think about how these things might apply in your particular context. Then we'll come back, and Stephen's going to talk a little bit about kind of the realities of trying to do this kind of ethical work live, I would say. So if I could get the next slide, please, that would be great. Okay, so this slide, this section, actually, if I could just get you to go back one slide, Kathleen. I just want to, my purpose here is to describe the sort of so what of this, right? AI ethics, great. What does it have to do with the web? Where are the points of intersection? This is very much an introduction, and given time, it's a very cursory introduction. You'll see some polls popping up. Please answer them as best you can. They're not attributable to anybody. We're just trying to get a sense of who's who, right? Thank you. Can I get the next slide, please? So now when we look at AI ethics in a research ethics board context, this is actually Kathleen's slide. I have stolen it. You will see it again later, but I wanted to use it right up front because what it does, I think, is set out some of the issues. So as a research ethics board member, and I'm rounding a lot of corners here, but grosso modo, you're concerned with two things. You're concerned with research participant well-being, and you're concerned with proportionality because it goes to the value of the research, which is the foundational question for research ethics board, which is this research sufficiently valuable to offset the potential risk to research participants, right? So these are your two big questions. On the AI ethics side, there are two major dominant sources of risk to both of those factors, and the nature of that risk is not always the same. You've got research data, which Obviously, if it's participant data, it includes things like privacy and consent. You're very familiar with those. It also goes to proportionality, though, because, and you'll hear about this from others, not great data can lead to catastrophically bad results, which means no societal value or potentially even a negative societal value, right? Then on the models and tools side, there's obviously the sort of direct risk to human participants if they're being subject to an AI thing that might do something wrong or harm them. But there's also, again, a risk to the value of research if you've got inappropriate use of a tool or use of an inappropriate tool. Okay, moving on. Next slide. Thanks. So this is going to be quite cursory, but I wanted to at least give you, and again, it's in the slides, download them if you don't have them already, an example of 3 approaches being used for ethics or responsible AI frameworks and principles. And there's different language and it does matter sometimes, but for this talk, the idea is just get a sense of what people are talking about and draw from that what is useful to you. So if I can get the next slide, please. So this is a Canadian meeting, and we, of course, have to look at the Montreal Declaration for Responsible AI. It's one of the leading documents in this area. It has 10 principles. They're on the left. The link to all of these materials, you'll find it at the bottom of the relevant slides. So you can open up the Montreal Declaration. If you've downloaded the slides by now, you can just open up that link and look at the declaration. I will drop that into the chat later on too. There are various purposes for which the declaration was created. I will let you read those at your leisure. And I'll move on, Kathleen, if I can get the next slide, to the OECD principles. So the Organization for Economic Cooperation and Development, of course, is it's an international organization. There we go. Yeah, OECD. I really wanted to flag a couple of things. Well, one thing on this, they have a number of recommendations. What you're seeing here is just an extract. But one of the things that these principles recommend is a focus. Governments, which I take pretty broadly to include public bodies, which often include research ethics boards in one way or another, being organisms often, not exclusively, but often of public bodies. To focus in on trustworthy AI and addressing challenges in AI, right? So it's just kind of a call to arms, if you will. Can I get the next slide? So here, the hero AI process is comparatively new. It's sort of last year-ish. And this is a product or a declaration of the G7. They have 11 principles. What I really want to flag here is one, a lot of important signatories to this. It is a G7 document. This encompasses the end-to-end of AI. So it includes everything from development, which could be research. It could be further development of a platform that's come in, anything like that, right through to deployment, which could be use in research potentially, and beyond. So, you know, when they say that they are looking and interested in managing the risks and protecting individuals and society, they mean end to end. There's no research exemption here. Okay. Can I get the next slide, please? And I see that a majority of people disagree with me, but that's fine. You're free to disagree. I will say, and I promised Stephen that I would say quite clearly, even on this panel, we disagree with each other a lot of the time. And depending which two you pick, it may be most of the time. But the important thing is to have these conversations, because without the conversations, we cannot move forward in anything like a coherent manner. So here comes the real so what. What does this have to do with you as Research Ethics Board members addressing the TCPS2? So you saw this earlier on my pirated slide, proportionality. right? The research has to have value in order to have a weight that counterbalances the risk to participants. And, you know, as we all know, there's always going to be at least some de minimis risk to participants. There's a risk every time I pick up a pencil, right? It's just so small we don't think about it. But the research has to have some value to offset that, right? And I've outlined here 3 types of issues that go to proportionality. There are others. In your small groups, we're going to invite you to discuss these things. So again, if you haven't downloaded the slides, do. You can go through these, see if there's anything there that you like. Maybe you dislike it and you want to argue against it. That's fine too. But, you know, this material's here. Can I get the next slide? Now, where most reps spend most of their time, research participant risks, right? And from an AI perspective, the majority of those falls into 1 of 3 buckets. So data collection and storage, this is kind of meat and potatoes for most research ethics boards, right? AI model specific privacy risks. That is, there are different types of risks that can be attendant to the use of AI or the development of AI models. And then, so privacy risks, of course, leakage, and then also the risks that actually come from the behavior or misbehavior of the AI model itself. Next slide, please. I forgot to set my timer, but I'm pretty sure the advice is just keep moving. So here are some points to consider, right? AI ethics does tend to look at broader societal impacts, which is relevant under TCPS2. And also, there are elements within AI ethics that do look at individual risks as well, which is where Rebs often spend more of their time. But you can't make the same assumptions necessarily where AI is concerned as compared to other things. Linda's just reminding everyone to put your questions in the chat. I'm not going to read through the others, but do consider them as we go into small group and going forward. Next slide, please. So the next couple of slides are my last 2 slides. I had wanted to sort of walk you through and apply the Montreal Declaration principles to certain types of questions that I've sort of digested into REB context. I'm going to do it very, very quickly. Can I get the next slide? So if we look at risks arising from data used in research, right? So there, Montreal Declaration has an equity principle, right? This can relate to bias, other things as well. Also prudence, right? Is the data sufficiently representative to give valuable types of outputs, right? And then there's research participant risks, 2 different types of risks, both of which kind of fall under the privacy principle. Can I get the next slide? Risks arising from AI models and tools. This one's a little more subtle, but again, for the prudence principle under Montreal Declaration, for example, leaking of sensitive training data. And let's be clear, I don't want to suggest that these are exhaustive lists. They're just examples, right? Kind of giving you some affordances so that you can get at this in your small groups. Risks to proportionality of the value of the research, well-being, so competence of the research team. There are so many off-the-shelf AI research support products out there now. You can't assume that every team really knows how to deploy them. I will tell you in my day-to-day life as program leader, I do not approve AI projects, AI-enabled projects, unless they have an AI expert on the team, even if they're just in an advisory role. Somebody who really understands the limitations of the tools and the way these things need to be used to be meaningful. Otherwise, you know, bad things can happen despite best intentions, right? And again, we've discussed it before, well-being, the well-being principle under Montreal Declaration also would address things like biased or inaccurate models. So I do believe that is it for me. Can we get the next slide? Yes. So I'm going to hand you over to Dr. Terry Stewart, who's going to talk about AI a little bit. I will caution for those who are math-ophobic, there are a few equations in here. Don't worry about it.
They're not
Terry is going to
important
walk you through.
equations. They're not important equations. I just like them on the slide. Hello, everyone. Yeah, next slide, please. What this, we certainly don't have time to talk about everything about what AI is, but at the really highest level, I do just want to get us all on the same page. And I really just want to force us thinking about things. The vast majority of these AI systems really are just a thing that takes in input and produces some output. And the sort of the classic example that we've used to have is, all right, here's a picture, and I feed in the picture and the output is, yes, it's a cat. Or feed in a different picture and it all says, okay, that's a cat. Another picture, it's a dog. Another picture, it's a dog. That had been around for a long time. The thing that has really gotten a lot of AI much more generally used, and I saw in one of the poll questions that a lot of people had used ChatGPT. ChatGPT is really doing the same thing, but it's just the input is some text and the output is the next word. So if I fed in my favorite animal is it might output dog. And then the way it generates full text is it just sort of repeats that process. So if I feed in I like to, it might output the word go. And then if I feed in I like to go, it might put out for, and then walk. And that's how it will build up all of this text. But it's all still in this same space of I feed in some inputs and it produces a particular output. And then as sort of, same sort of structure with this sort of generating of images that people might have seen with DALL-E and other, the image generation stuff. Again, still the same story. I'm feeding in some text. It's outputting an image. And just like in the, what's the next word, there might be multiple other next words. Again, if I feed in a cat, I might get multiple other images of cats. But I just want to, it's that same framework all the time, feeding in something and I'm getting an output. Next slide, please. How does that actually work? Yeah, lots of math. But if you are familiar with regression, it's just fancy regression. But then the important thing is, again, next slide, that even as the math gets more and more complicated, all it's doing is it's shoving in the input as some numbers, doing a bunch of math on those numbers, and then whatever the result is your final output. And the learning process, the training process of these AI systems is just adjusting the math in the middle there, so that the math does a good job of producing the correct output. Let's go on to the next slide, please. Because that correct output is, I think, where we start getting a really an important aspect that this body really wants to consider, that this is where a lot of our problems can start coming up. When we do that training of the AI algorithm, we're asking it to optimize for something, and that something is usually accuracy. So I have a bunch of initial data of, okay, given this text, here's the word that comes next. And we're trying to optimize it to do the best job of accurately predicting what that next word is in this big set of training data. So this is where we get into the aspect of, in order to train these models, we need to collect a large amount of data, because that's the data that we're saying, okay, this is your gold standard, this is what you're trying to do. There's some terminology around that of either loss function or objective. But the key thing is that whatever these things are trained on, that's what they're going to do. And we shouldn't expect them to do other things. The subtle sort of, so we'll talk about a consequence of that in a moment. But this core thing of training up this math, this is where we need lots and lots and lots of data, and where we have to be really careful about what we're asking it in terms of what is a good output. Can you go to the next slide, please? So with that sort of very, very basic context, we've got already some interesting questions. This is where all of this privacy questions come from. Where does that training data come from? How do we get this giant corpus of data? the amount of data that these things are talking about tends to be so large that no one can actually go through the data and even see what's in it. These things are literally just sort of trained on the entire internet, and that's just too large a data set for anyone to really go through and validate and see what's in there. Even in the ones where you're training images, you have to get somebody to go through and say, okay, for this image, here's the correct output. Someone has to do that, and that, of course, process itself can be wrong, or is very expensive. There's also this fascinating aspect of security. This was mentioned earlier, but leaking information. If you have, for example, somewhere in this entire training database of ChatGPT, someone's credit card number, and then if I type the sentence into ChatGPT, my credit card number is, and ask it to complete the sentence, it can leak that data. It can, fill in a valid credit card number, if that valid credit card number was in its training data, which is sort of a, in hindsight, it's sort of obvious that it can do that, but that was sort of a big surprise when it was first realizing that that sort of thing can happen. Okay, next slide, please. I want to finish my last example is sort of going back to that comment about what these systems do is try to optimize for accuracy, for prediction accuracy often, or at least if, by default, if people don't tell you what they're optimized on, that's probably what they're doing. We get this really interesting example of making bias in the data worse. So for example, if I have this sort of training data, say it's a giant database of text, but it has in it somewhere there phrases like my favorite animal is a dog or my favorite animal is a cat. But the favorite animal is a dog shows up a little bit more than cat. So we're looking 60% dog, 40% cat there. If you optimize an AI system, to be accurate, well, I mean, so one thing that we would sort of intuitively think is, oh, okay, the right thing to do would be to output, if I feed in my favorite animal is and I ask you what word comes next, it feels like the right thing for a network to do would be, okay, 60% of the time it should say dog and 40% of the time it should say cat. If we do the math on what that accuracy means, if you did that, you would get it would be making a right guess 52% of the time. But if it really wants to be accurate, it should just guess dog all the time, because if it guesses dog all the time, it would be 60% accurate. This is the source of why AI systems make bias worse if you only train them for accuracy. Anyway, I wanted that as just an example of it's not just enough to make unbiased data sets. It's not just enough to look at bias in the data sets itself. The actual creation of the AI systems and what they're trained to do can also impact this process. All right, that was a whirlwind introduction to AI and what it's doing. I hope that was at least somewhat helpful, and to just give us all the sort of basic context. Stephen, on to you.
All right, well, thanks very much. And I just want to say I'm on team cat, not team dog. Let's be clear about that. So to me, all of the answers are inaccurate. No, I'm just kidding. I come at this from a background not only in technology, but also in philosophy. And oh, stop calling me. Sorry, somebody keeps calling me right in the middle of this presentation. Now they've messed me up. Sorry about that, and I can't get rid of them. There we go. I know I should make my phone not callable. Never mind. Okay, it's interesting. What are the ethics of phone calls on presentations? I actually was doing a presentation once, and I just took the call during the presentation. Anyhow, What I want to suggest here, and this runs against some of the stuff that was said earlier, is the idea that there is a common understanding of ethics. And we saw at the beginning of this presentation, the Montreal Declaration, the OECD, and the New York Hiroshima. As part of work that I've done, I've reviewed dozens and dozens and dozens of these declarations, manifestos, research findings, reports, etc. And they're all different, and they all have a different basis. And I want to explore some, in this part of the talk, I want to explore some of these bases. Slide, thank you. So I'm going to survey basically for leading AI, or maybe 5, leading AI ethics approaches and perspectives. And what these are the ethical background or the ethical theories that inform what our ethical practices actually are. And just as a bracketed aside, a lot of the time we just equate ethics with some sort of legal statement that's ethics. Ethics is law, for example, but ethics is not law. And even where law comes into it, as it very often does in Research Ethics Board, the idea is that the law in some way represents or codifies the ethics prevalent in a society. But where does that ethics come from? First area is culture and virtue. The idea of an ethical person, or the cultivation in oneself of inherently ethical qualities such as honesty, fidelity, loyalty. There's the concept of arete, be all that you can be. You may have seen that in advertisements. There's this idea that ethics is in some way a medium between deficiency and excess. That would have been the Aristotelian expression of ethics. And we see this reflected a lot in AI ethics. For example, in issues around impacts of research and research methodology on the individual, loss of skills, loss of critical reflection, loss of a sense of right and wrong. We see virtue-based responses in things like standards of professional conduct. Many of the ethics statements were actually part of standards of ethical context. And a lot of the times we see this perspective, this character and virtue perspective, represented in what might be called values-based ethical principles or ethical approaches. For example, academic freedom, which is something that comes up a lot, scholarly excellence comes up a lot, mutual respect, collaboration, integrity, things that are widely cited. And even right off the bat, without even moving on to the next one just yet, contrast what you just see right here with an expression of ethics, AI ethics in research as, say, risk and proportionality, right? Already we see a significant difference. There's no estimation of risk here. You don't become a virtuous person by minimizing risk. It wouldn't even make sense. Next slide, please. Another very common and very popular ethical perspective is based on the idea of duty or deontology. Derives mostly from the philosophy of Immanuel Kant, but there's been a lot of work on it since. There's 2 major thrusts to this. First one will be familiar to everybody. The inherent value of life. For Kant, that's human life, and more particularly, rational human life, which in Kant's time probably meant men only. But of course, we would reflect that very differently today. And the question would be, which lives? All lives, human life, animal life. There have been some recent statements about consciousness in animals, and maybe that should change how we think about the ethical standing of animals. The idea, though, is that each person should be thought of as an end in themselves, a good in themselves, or to use today's market-driven kind of terminology, each person has their own inherent value or worth. So that's the one part of it. The other part of it is the application of what's called the categorical imperative, which is the same rule you apply to your children sometimes. You ask them, what if everybody did that? The kid wants to walk across the corner of the lawn. Well, what if everybody did that? You'd ruin the grass, etc. These apply directly in AI ethics when we raise issues based on rights and agency, including questions of surveillance, tracking, anonymity, privacy, etc. There are also many ethical documents, ethical principles documents based on the dignity and worth of each human. The National Education Association, for example. Certainly, we hear a lot about role and responsibility, and that falls in under this heading of duty. And then the idea of informed consent is a reflection of the idea that each person is an end in themselves, is valuable in themselves, therefore worthy of getting consent from. Next slide, please. Another leading AI approach is consequentialism, known mostly for the theory of utilitarianism, although there are other kinds of consequentialism. The idea is producing the greatest good for the greatest number of people, typically expressed as the happiness principle, the presence of pleasure, the absence of pain. Now, of course, what counts as pleasure and what counts as pain can be debated. There are different flavors of utilitarianism. Do you just follow whatever act makes the greatest good for the greatest number, or do you express it in terms of rules? It's two different types of utilitarianism. Is it a rule that applies to everyone or just in most cases? And what counts as good? Is good just pure physical pleasure, as you would see in hedonism? Or is it, cultivating the intellectual pursuits, as John Stuart Mill would say, the higher pleasures? No matter. Consequentialism is where we encounter issues of risk in AI ethics, because here we're looking not only to maximize the greatest good, but to minimize the greatest harm, right? So risk-based approaches are based on the idea of minimizing harm. Now, again, minimizing harm does not necessarily mean maximizing good, which is why there's this proportionality. But aside, proportionality doesn't always work here because it isn't always a middle ground. A benefit-based response would also be an application of this principle. So when we look at things like the safety of people, the health of people, the welfare of the public, as in the IEEE code, that's what we're looking at. The Health and Human Services Common Rule, a well-known ethical principle, focuses on the reduction of harm. Slide, please. Another major, it's not even, a lot of people don't include this among the list of ethical theories, but I do, is social contract theory or contractarianism in general, where ethics is based on agreement for the greater good, presumably the greater good, mostly just agreement. There's a long history of this going back to people like Hobbes and Locke. The contemporary formulation is expressed by John Rawls in his book, A Theory of Justice. And the theory of justice that Rawls says that people freely entering into a contract would agree to is a principle of justice as fairness. It was very influential, and a lot of ethical principle today is based on this principle of fairness. Not so much in the area of AI ethics, which is kind of interesting, but there are some applications. For example, when we're concerned about undermining decision-making and democracy, content manipulation, micro-targeting, discrimination, this is attacking the principle of fairness, right? And it is that principle that would speak against them. When we're looking at society-based responses, you know, the need for regulation, for example, the need for enculturation, I don't want to say social control because that's too far, as for example, evidence in the Code Soleil, that's an example of social contract in action. Promotion of the public trust, as proposed by the Ontario College of Teachers, again, is based in the whole social contract theory. A lot of what we do on REBs, based on constitutional and rights-based approaches, the origin of that is social contract theory. And so it's, for me as a philosopher, it's an interesting question, right? Is social contract even a theory of ethics? If not, arguably it's not, then why is social contract being used as the basis for ethics in our research ethics boards? It's a conundrum. Next slide, please. This is the last
Stephen,
one.
sorry, Stephen, it's time for the 10-minute break. Do you mind if we just leave it here and continue after?
Can you give me 1 minute and then I'll just be done?
Oh, sorry, sure.
Okay, this is the last one. It's very important in a lot of recent work. It's care-based and community-based ethical principles, where ethics isn't based on a set of principles or values or contracts, but rather is based in personal relationships and interactions, negotiated basically in the case of in each individual relation of one person with another. It's based in a sense of ethics rather than rules and principles. It's an affective rather than a cognitive type of ethical principle. And here, when we look at issues of alienation, dehumanization, creation of climate of mistrust, fear, anxiety, that's the sort of thing that gets raised when people are coming from a care and community-based ethical perspective. So there's some links on the next slide, which I'll just skip over, that point to a lot of these, a lot of this research in the background. I'll be coming back a bit later and we'll pick up this discussion after our group discussions. Now we can break.
Sorry about that, Stephen. I didn't
No,
realize we
I
only had
totally
the one slide
understand
left. Okay, everybody,
and
we're gonna
maybe-
break for 10
yeah.
minutes.
Yeah, so Linda, if I can just take one moment, Kathleen Fraser will speak when we come back. We're just adjusting the schedule a little bit due to delay. So everybody please come back. Kathleen's presentation, I would say, ties everything together. And then we'll do the small groups. Thanks.
Welcome back, everyone. I hope you had a good break. My name is Kathleen Fraser, and I'm a computer science researcher here at NRC. I work on natural language processing and responsible AI, and I am not an REB member, so please forgive me in advance for that. My goal for this session is really to take some of these kind of more abstract concepts that we've been talking about and make them a little more concrete by going through some real-world examples of AI research projects and thinking about how we might apply some of these ideas in each situation. And as I go through, I'll be asking a lot of kind of open-ended questions. So please feel free to comment in the chat so we can get the conversation started, and then we can continue these discussions in the small group sessions. So I'll just start by reiterating what Margaret said at the beginning. When we think about AI ethics, specifically in the REB context, two of the main risks are related to participant well-being and proportionality. So kind of this trade-off between the risks and benefits of doing the research in the first place. And two of the main sources of these risks are the data and how it's obtained, and then also the use of AI models and tools themselves. So my plan is really to go through each of these four categories and think about some real-world examples that help represent some of the issues that we might see in each category. So if we start by thinking about research data and participant risks, I think one of the big questions is really, have the users actually consented for their data to be used for this purpose, and would they consider it a breach of privacy? And so the first example that I want to talk about, I'm sure you've all heard about, is the Cambridge Analytica scandal, which involved the data of 50 million Facebook users being acquired by the company Cambridge Analytica, who then used the data to try to influence voting patterns. And one thing that I hadn't realized about this when I first heard about it is that the data that was scraped from Facebook was actually collected by a academic researcher from Cambridge University. And I was not conclusively able to figure out from looking online if he had ethics approval to do this research. But what he was doing was not considered, out of the ordinary for his department, which involved creating kind of a psychology quiz and releasing it on Facebook to users. And all the users who took the quiz consented in the sense that they clicked some box on the internet saying, yes, you can use my data and you can use all my friends' data too for research purposes. Now, none of the friends were involved in the consent process at all. And crucially, sometimes this is described as a hack. There was no hack. Facebook wasn't hacked. This was all done completely within the Facebook terms of service. It was totally allowed. Now, what came afterwards was that the researcher, Dr. Kogan, sold or gave the data to the company, Cambridge Analytica, and that was definitely not allowed. But I think it's interesting to think about everything that came before that. Like, was it okay up until that point? And some of the questions that I have when I read this are, does clicking a box online really count as informed consent? What about this idea that the user could consent on behalf of their friends? Like, how do we feel about that? And if we're following the terms of service of a website, is that kind of enough to sort of cover our backs when it comes to that data collection? Because, AI is very data hungry. We always want more and more data, but we just need to make sure that we're collecting it in, a sort of appropriate way. The next example along the same lines, this is what became known in the popular media as the AI gator. And what that was an AI system that was built by a Stanford prof and his student, which would take as input an image of a face, and then it would attempt to predict that person's sexual orientation just from the picture of their face. And this is the kind of project where my first question, honestly, is like, why would you even do that? But I've been told that it is not the purview of REB in most cases to make kind of value judgments about whether the topic of the research is worthy of pursuit. So we'll put that question aside for later. But just thinking about the data, so here the images and the labels for sexual orientation were all scraped from online dating sites. And so the questions that I kind of want to pose in this scenario are, is this data in the public domain? Did the users have a reasonable expectation of privacy when they posted their photos and information about their sexuality online? And if they had been asked, do you think that they would have consented for their data to be used in such an application? And so we're doing some polls as we go through too, and we'll make sure that we take a look at the results of those at the end. I'm very curious what you have to say. The second aspect that we talked about in terms of data is the proportionality risks. And one way that this comes up with AI research is the question of, are there sources of bias in the data which will limit any potential sort of value or benefit of the research? And so one example of this is this sort of now infamous case of Amazon's failed attempt to use AI to help with hiring decisions. And the reason that it failed was that even though they didn't include applicant gender as kind of an input, they still found that the algorithm replicated the company's historic bias for hiring men over women, because it learned that when a resume mentioned something like a women's college or a women's sports team, that this was associated with the kind of person who is less likely to be hired by Amazon in the past. It also picked up on some really kind of subtle things. It gave higher weight to resumes with words like executed or captured, because it turns out that these are words that were more likely to appear on men's resumes. And in the end, they really couldn't use the AI system at all, and they got a lot of bad press about it. So questions that we might ask in a similar scenario are, what's the likelihood that the training data for a given project contains systemic bias, and can that bias be removed or mitigated in the training process? Keeping in mind that in the real world, simply like not including gender or race or age or so on as an explicit input to an AI system is not enough to ensure that that kind of bias won't be learned by the system. And in fact, it can be really important to know these demographic variables wherever possible, so that you can actually test that your system works fairly for different groups. Another place where problems can arise is when you try to train a machine learning model on data that doesn't actually contain the necessary information to make a valid prediction for your task. And so this Scientific American article discusses a research project that aimed to use AI to design diabetes treatment plans for lower socioeconomic status groups. And this kind of sounds like a good idea, right? Like it should be helping underprivileged groups access healthcare. It's all good. But they actually criticized this project because the model was trained on medical records. So things like lab tests and diagnostic codes and so on. And it didn't take into account any social determinants of health, transportation options to the medical center, issues of food insecurity, employment status, things like that. And often people want to train AI models on kind of the data that they already have lying around, but we have to ask, like, can you actually learn what you want to know by sort of just pushing this existing data through a neural network? Or do you actually need to do the harder work of going out and collecting the kind of data that will actually have a net positive impact on people that you're trying to help and on society in general? So if we turn now to the whole idea of the AI models and tools themselves and kind of testing them on human participants. So here we want to ask things like, how does the AI tool use the participant data? Is there any chance that it could be leaked or exposed by the trained model? And is there a chance that the research participants themselves could suffer harm through their interactions with the model? And one example where this happened, this was just recently actually in the US. They have this National Eating Disorders Association, and they shut down their kind of long-term like telephone-based helpline and replaced it with an AI chatbot, which was kind of a fine-tuned version of a third-party mental health chatbot. And when I looked into this, I was actually pleasantly surprised to find out that this chatbot had been thoroughly tested in a clinical trial with university researchers. It was found to be safe. It was found to be effective at reducing short-term eating disorder risk. So I think, they did everything right. But unfortunately, what happened is that at some point in between when they did the clinical trial and when they deployed the chatbot, the chatbot company made a quote systems upgrade that incorporated more AI into the chatbot without the researchers knowing. And this upgraded chatbot ended up giving diet advice, ended up promoting like caloric deficits and so on and so on. It's obviously very dangerous for an eating disorder chatbot. So they had to pull it from production. It was a big news story. And here, I think one of the big questions is, who controls the technology? If the researchers are using a third-party AI tool, can they control which version they're using, or is it going to be a kind of situation where the owners of the technology are constantly making little upgrades and changes that the researchers can't control, and that in fact they might not even be aware of? There's also a potential risk to privacy when working with AI models, and I think Terry and Margaret already touched on this. There was a study at Berkeley that showed that if you prompted GPT-2 in the right way, it would give you actual names and phone numbers and addresses of real people. And this was information that was on the internet in the first place, and that's how it ended up in the training data for these models. But it just underscores that once the data has been used to train an AI model, there's always a chance that it will output that data to another user. And this problem persists in more recent models like GPT 3.5 and Llama. So we have to be careful, especially if training a new AI model, that participants' personal information will not be leaked by the model. And now finally, we have kind of the proportionality risks associated with using AI models in research. And we have to ask, how well has the AI tool been validated for the proposed purpose? And does the research team have the expertise to use and understand the AI model? And for this example, I'm actually going to be vulnerable and use a story from my own research. So in one project, we are using a webcam to track participants' eye movements as they use a computer to conduct a cognitive assessments. And our target population for this is older adults. And eye tracking with a webcam is a lot harder than eye tracking with kind of a regular infrared eye tracker, but it's much, much cheaper, which is why we're using it. But you basically need an AI model to map from what the webcam sees, which is a picture of your face, to the actual XY coordinates on the screen of where you're looking. So we are using a pre-trained third-party AI model to do this eye tracking, and it seemed like it worked really well. And we tested it on our colleagues, and it still worked really well. And then we tested it on older adults, and it didn't work at all. And we dug into the details. It turns out the oldest person in the training data for that model was only 41 years old. So fortunately, we have people on our team who have the kind of AI expertise that you need to be able to adapt and modify the model for this population. But it highlights questions, I think, of if you're using a third-party tool, has it actually been validated on the population that you're interested in? And if not, does the research team have the ability to adapt or retrain it if necessary? So that was really fast, sorry. And these are all examples of questions that I think REB members can be asking today about AI research projects that come over their desks. But in closing, I do just want to point out there's a lot of AI research going on that is never reviewed by REB because it doesn't involve direct participation of human subjects. And I think there's also this sort of disconnect between protecting research participants versus protecting the people who will actually be affected by AI research in the long run. And I think this is expressed sort of nicely in this quote. There's a large gap between the relevant concerns that follow from AI research and those that fall under the purview of IRBs. Issues like dual use of data, worker displacement, unrepresentative training data, and excluding stakeholders from project design and deployment remain unreviewed and often unmitigated. And so thinking about that gap and how it can be addressed, I think is also some food for thought and conversation for the rest of the session. But that is it for me. I'm going to pass it over to Margaret so that she can talk about the breakout sessions and the structure. Thank you very much.
Thanks very much, Kathleen. So I'm going to be sending you into breakout groups, and I'm going to drop into the chat. I've been fiddling around with it. I apologize. There was an initial attempt that didn't work particularly well, but I'm dividing you up based on your response to the original question around how, what types of technology are you most engaged in your REB role? So I've just dropped into the chat now the two questions, A and B. What areas of AI ethics do you feel? And then B, based on structures and principles of the Montreal Declaration. These are your two questions for the breakout groups. You're going to have about 15 minutes. My suggestion is just stretch, sort of 7-sitting stretch, but don't actually leave your computer, because I have to trigger the poll to take you to your breakout rooms. And I will say I'm only half in control of this technology, and that's being generous. So it is quite possible that we may have to move some people around. Plus, if you didn't respond to poll B, you'll have to be assigned manually. You can see which teams are focused on which subjects from the chat. I will try to enable you to manually select if you either aren't automatically assigned or don't like your assignment. The 4 of us will be bouncing around. The other thing I'm going to do, this is very important, please record your documents in the Google Doc that is assigned to your topic. So there are only 4 Google Docs, and there are more than 4 teams, because, for example, half of you define yourselves as being predominantly involved with social science. So that's obviously more than one breakout group, right? So you're just going to have to choose different parts of the documents. So I'll invite everybody to find some white space and start with that. So just 7-sitting stretch, take a minute, and you'll be going into the breakout rooms. You probably will have to click accept to go in. Thank you.
I'm going to toss, my chat disappeared again. I'm going to toss a couple links into the chat. And these will relate to these remarks. This isn't actually a summary of the Google Docs, because even I cannot read and prepare a summary and talk about it in the space of 1 or 2 seconds. Would that I could, though. If I had an AI, I could, right? I could just have the AI do it and then summarize it. That would be cool. But even in the small group that I was in, you could sort of see, you know, like they look at the Montreal Declaration and they said, well, yeah, but this doesn't really apply to what we do. Different disciplines are going to have different perspectives. I really saw that in my own survey of documents on ethical principles. And there's, you know, we're in this state right now where there isn't yet a commonly accepted doctrine of ethics and AI. And it's funny because I think a lot of the time we expect it to come from somebody externally, but we're in the position, especially research ethics boards members, we're in the position where we have to have a say and make that say heard on what actually constitutes the ethics of AI. It is certainly with respect to research. And in so doing, I think we have a responsibility to, well, first of all, challenge some of the often held ideas about ethics, because we see these statements come from University of Montreal or from OECD or IEEE or the House of Lords in the UK. And a lot of them suppose that they have a handle on what ethics are. And there's this idea, the first link that I put into the chat from Luciano Floridi, oops, don't go back, thank you, talks about, oh yeah, everybody has the same idea about ethics. But I don't think that that's true. We even had a small discussion on ethics in our own research group here at NRC, and it's like 8 people. There were 8 completely different theories of ethics that were proposed. Also, the idea that, you know, ethics is prescriptive and describes attitudes that we should have or how we should behave. That's often the approach that we take in research ethics boards. But we also need to ask whether ethics, properly so called, are as much reflective of values that already exist in society. And then third,
Stephen,
yeah.
just 1 second. I'm just going to ask everyone to please mute your microphones. Some people are getting a really bad echo.
Okay.
Please double and triple check if you're not Stephen Downs, that your microphone is muted. Thank you.
Which led me to immediately have an identity crisis. Am I or am I not Stephen Downs? Third is this idea that moral principles can be expressed as a series of knowable rules. And I mentioned earlier the ethics of care and community. And here we're talking about people like Carol Gilligan, Bell Hooks, and others who explicitly say, you know, ethics is exactly the opposite of a set of knowable and followable rules, and that this perspective represents kind of a male-centered positivistic approach to ethics that doesn't really apply in many situations involving care. And I think there's a point there. Slide, please. Oh, that little diagram at the bottom and there's the link on the slide, is a report on different types of studies and how, or different types of societies and how these societies actually value things like community, property, etc. differently. Second question is to ask even, what is the basis for ethics? There's different types of ethics, descriptive, more normative, analytic. But even more to the point is the question of whether ethics can be relative to the culture, relative to the person, relative to the person speaking, and the question of whether ethics, again, describe or prescribe. There's the idea of non-cognitivism, where moral discourse isn't really ethics properly so called, but just a way of communicating with each other to try to communicate our ethics, but it's not actually ethics. Are there even, you know, ethics in nature? You know, J.L. Mackie wrote a book called Inventing Right and Wrong, with the argument that, you know, nothing is right or wrong in nature. It's just something that we bring as humans, as society, to the table. I think that's a fair question. There goes my phone again. And something that matters to me a lot is our ethical decisions a matter of rational choice versus intuition or sentiment? When we sit down at ethics boards, and we're determining the ethics of an application, are we following a set prescription set of rules? Well, yeah, but in the margins where the rules don't prescribe, because the rules can't be completely prescriptive, how are we deciding? Intuition, sentiment, gut feeling? And then what's the basis for ethics? Is it a deity? Is it God? Is it power? Is it, you know, there's the power of the institution to rule on something? Is it reason and rationality? Is it, as I suggested earlier, ethics by agreement? Or is it the feels, how we feel about a thing? Finally, the most important question, next slide. Who owns ethics? And that's why I say, as members of ethics boards, we need to take some responsibility here, because ethics isn't something that's just brought in from the outside and applied to us, at least not in my opinion. You look at the different ways ethics are expressed. Scientific virtues. As scientists, we think in a certain way and bring certain things to the table, and often invoke some idea of a theoretical virtue, objectivism perhaps, you know, the saving the phenomena or relying on the evidence, things like that. But also come from a completely different domain is the whole realm of business ethics. That comes into play a lot and often conflicts with scientific values. And, you know, it's often expressed as practical and pragmatic concerns, real concerns and real world problems faced by the vast majority of managers. I was just thinking in my head, you know, the business problem would be, can we cure cancer? The scientific problem would be, can we do it without violating principles of privacy? Two different questions. And then, just for fun, there's the Silicon Valley ethics. And the second link I threw into the chat was the Mark Andreessen manifesto. Now, just to be clear, I do not support even one word of that manifesto. I think it's a piece of crap. But a lot of people don't. And the people who build a lot of the technology that we work with don't. And like it or not, they get a say too. And therein lies the problem, right? We might not like crass consumer capitalism, free market everywhere, margins in everything, everything's for sale, even personal data, even lives. But to some degree, they have a seat at the table. And that's the kind of environment that we need to navigate. Again, we could say, okay, well, there are these declarations, the Montreal Declaration, et cetera, et cetera. But again, I ask, who put them in charge? Nobody put them in charge, they're self-appointed. And they represent, to a large degree, the scientific, business, and commercial elite. And let's be honest, us, right? But that's not where ethics comes from, ultimately. In my view, ethics comes from a culture or a society as a whole. And that means the culture or society as a whole has to have a say in it. That's all I got.
Thanks very much, Stephen. And thank you, everyone. I know we're 5 minutes over time. Really appreciate it. Your patience here. We will, the speakers, that is, we will stay on the line for a bit. I know many of you probably have 4 o'clock meetings, or at least 4 o'clock engagements that aren't this. But we'd be happy to talk either at a more theoretical level or at a more technical or pragmatic level, to Stephen's point. But thank you all. If you do have questions, feel free to reach out. I think all of our contact information is in the various slides. The contact information on the slide you're seeing right now is the generic mailbox for the Digital Privacy and Security Program, which I lead, and I can also triage your comments. So with many thanks to Carib and to all of you. I hope you have a wonderful evening.
Thank you very much for your great talk. Learned a lot of really new stuff, really great stuff. So thank you again. And if everybody wants to go back to the main stage for the closing remarks for the day. Thank you.